One ball rolls to the right at 2 meters per second and has a mass of 400 grams. A second ball rolls to the left at 4 meters per second and has a mass of 200 grams. If the two balls experience a totally elastic collision, what are their final velocities? And I've written here for us the formulas that we derived in the last couple examples for totally elastic collisions, and I think I can just plug into those formulas to answer this question. One of those final velocities in that sense is v1, so I'm just going to try to plug into this. What could possibly go wrong, right? So let's see. We have, I think for m1 and m2, right, if I'm going to say that in terms of 1 and 2, the first ball described represents mass m1, so it's m1 in that sense is going to be 400 grams. v1 naught is going to be 2 meters per second. Second ball is going to be the one that has the mass of 200 grams, right? So that hopefully that means we'll be able to get these numbers in there correctly if we recognize where everything's coming from. Okay, let's go ahead and do that. So we got 400 grams. I'm going to not write the units for this just in the interest of space, because I know that when I do 400 grams minus 200 grams and I divide by the sum of those two, which is really 600 grams, right? Because 400 plus 200 is 600. But I know the grams would cancel out of that expression. So basically, I'm doing this first term right here in case it's not clear where I'm getting these numbers from. And then V1 naught against for the first ball. So that's the 2 meters per second. So I'll just put 2 meters per second here. Okay, and then I'll look at that formula here. Plus 2, let's see, that's M2. That was the 200 grams, right? So 200 grams divided by 600 grams. Oops, I said I wasn't going to do the units, then I accidentally wrote one, so let me just get rid of that. Okay, because otherwise I got to write one down here too, right? So I didn't want to do that. All right, and then this is V2 naught, the speed of the second object. Oops, I shouldn't be writing just the V for that. I should just write the quantity, right? 4 meters per second. So let me pause for a second, or maybe I'll say if you want to, you can pause the video and tell me if you see a mistake in any of the plugins that I did here. So if you're coming back from that pause, maybe you found my mistake, but I'm going to now reveal what it is. The big mistake that I made is this should have been a negative 4 meters per second. And I think maybe the biggest mistake that I made here is I never drew a picture. I never really wrote down my variables. And sometimes when we're in a haste, we don't want to do all that stuff, right? But maybe I could have saved myself from the mistake if I'd looked at the problem description and, again, drawn a little sketch. So if I said, hey, here's 400 gram object moving at 2 meters per second to the right, as it says. But now here is that second 200 gram object, so I didn't make any mistakes with those masses, right? But this one is moving to the left, right? This one's actually moving to the left quite a bit faster, or twice as fast, right, at 4 meters per second. And now it's a little bit more obvious that if I consider rightward motion to be positive, leftward motion should be negative, right? And so again, clearly connecting this picture to what I'm doing when I plug into these formulas is, I think, an important component. If you wanted to make it even more clear, you could go to the step of saying hey, my M1 was equal to 400 grams, M2 is equal to 200 grams, and I don't have a lot of space there, so I'll go over here. V1 is equal to 2 meter per second, and V2 is equal to, and this is the part where if I really wanted to make sure I didn't screw up. Actually, wait, I think I did screw up. These should be V1 naught, right? But anyways, if I want to make sure that I don't screw things up, having that list very clearly will make it harder for me to accidentally, plug into this formula without thinking too hard about it and make a mistake like this. And I'm mentioning this because I've seen this happen a lot. I've seen a lot of minus sign mistakes where somebody almost gets it right, but they make one little minus sign mistake and then the answer turns out wrong. And usually if I'm able to grade for partial credit, I generally tend to be forgiving about that. But maybe if you're in a situation where you're not graded for partial credit, which sometimes happens online, right, then the computer might be less forgiving about that, depending on what computer system is doing it. But anyways, let's go ahead and find this answer here. So 400 minus 200 over 600, let's see, that's 200 over 600. I think that reduces to 1/3 times 2 meters per second. This is plus, let's see, 2 times 200 would be 400 over 600, which would reduce to 4/3 times the minus 4 meters per second. Okay. And let me see, this is going to really be 2/3 minus 8/3. I think that's equivalent to minus 6/3. I would have maybe written some more of that out, but I need more space for the second one, so I don't think I'd have space. But minus 6/3 meters per second is equivalent to minus 2 meters per second. Well, that's kind of interesting that is the same magnitude of speed as the 400 gram object initially had, but when it bounces off, it's just really, this is saying it's going at 2 meters per second to the left instead of to the right, so it's almost like it just bounced off the other object. Maybe there's something interesting there, right? Let's look at V2. Maybe it'll do something similar to that, right? Let's find out. So now that we have our numbers more clearly stated there, but now I'm looking at this second equation. It's all kind of jumbled up here, but hopefully you can recognize where my second equation for me to plug in is located. And so let's see, 2 times m1, that would be like 2 times 400. I'm going to write that. I could have just written 800, but I don't want to do too much. Otherwise, it's easy to lose track of, did I do it all correct, right? So it's good to notate your steps as you go in a way that's followable. Let's see, this is going to be times 2 meters per second, and then we'll do plus. Now it's going to be, let's see, we're looking at this part right here, right? So let's see, that's 200 minus 400 up there, right? Because m2 was 200, m1 was 400. All of these are dividing by the total mass, so I don't have to think too hard about those once I've done one of them, right? But then we're still multiplying by minus 4 meters per second, so I'll make sure to get that correct on this one. All right, that was a little bit more space to write all that, but I still have some space down here, so I think we can do this. 2 times 400 is 800 divided by 600. I think that reduces to 4/3. I sometimes like to throw out the question, was fractions anyone else's favorite subject? And just for the record, I'm not raising my hand for that, even though you can't see it. Fractions were not my favorite subject, so hopefully I did that correct. Anyway, sometimes I screw these up, and I'm like, what did I do? Anyway, so now we have here 200 minus 400 over 600, so that's like minus 200 over 600, so that's really like, I'm just going to write it as plus a minus 1/3, because I think that's what that is equivalent to. And then we'll still have the minus 4 meter per second. All those minus signs, right? Let's see, this is 4 times 2 is 8/3, but these minus signs cancel, so it's 8/3 plus 4/3 is equal to, where's my calculator, right? 12/3. I left it somewhere. So yeah, so we got 12/3. Hopefully I did that all correct. Meters per second, but that is equal to 4 meters per second, which is maybe not so surprising what happened with the first one, because the first one, right, just it was coming in at 2 meters per second and it bounced off to minus 2 meters per second, and the second one did kind of the same thing. It was coming in at minus 4 meters per second. In other words, it was coming into the left, but this is saying after it bounced, it's bouncing off to the right. Wow, that's amazing. Are they all going to be that easy? The answer is no. The reason why this one turned out that simple and kind of symmetric looking is because the center of mass velocity in the initial state, or basically before the collision, was equal to 0. In other words, if you take 400 times 2, that gives you a momentum in maybe the weird units of gram meter per second of 800. But 4 times 200 gives you the momentum also of 800, but really that should be minus 800 to reflect the direction. So 800 plus minus 800, all in grams meters per second, is 0 total momentum. So it turns out that is special. This was something that Feynman really liked to emphasize, is that when you look at things from the perspective where the center of mass velocity is equal to 0, then you can just state what the answer is going to be without even doing any calculations if you know that the symmetry is going to be preserved. In other words, basically what was rightward motion becomes leftward motion. So he turned that into a methodology that I might share with everyone. But we can check our answer there. It says first ball is 2 meters per second to the left. Second ball is 4 meters per second to the right. And I think that aligns with the signs that I've reported with my final answers.